This is the most complex piece of machinery that humanity has ever manufactured. It is roughly the size of a double-decker bus, weighs well over 180 tons, and costs up to $400 million, or the exact budget for the final season of Stranger Things. To ship one single machine to a client, you need 40 freight containers, 20 massive commercial trucks, and 3 entire Boeing 747 cargo planes. It is by all accounts a logistical nightmare. And yet, if any nation on Earth wants to mass-produce the advanced microchips required to power AI, including the very AI contributing human creativity to make this video possible, they have zero choice but to buy it. In the modern global tech race, semiconductors have become a vital geopolitical weapon. Governments are panic-pouring hundreds of billions into building local chip foundries, but while superpowers yell at each other on television, the entire weight of human technological advancement relies on a single, highly specialized, relatively obscure Dutch company located right next to a quiet cabbage field, ASML. This is the story of how they built an unbreakable monopoly on the future. Today, ASML is a massive economic titan, but back in 1984, it was just a tiny, desperate side hustle spun out of a Dutch consumer electronics brand Philips and ASM International. They had absolutely zero street credit, no market share, and their very first commercial lithography product was a catastrophic failure that famously leaked hydraulic oil all over the customer's pristine, sterile, clean room floors. It wasn't exactly a great first impression. During this period, Japanese corporate giants like Nikon and Canon absolutely dominated the global lithography market. They were massive integrated empires with bottomless corporate budgets that built every single component entirely in-house. ASML, on the other hand, chose a strategy that was heavily mocked. They decided to outsource all of their parts. Instead of engineering everything from scratch, ASML shifted their focus entirely towards system integration, software architecture, and modular engineering design. Think of it like a multi-million-dollar set of Lego blocks. If an intricate component broke down inside a fabrication plant in Taiwan, engineers didn't need to rebuild the machine. They simply yanked out the broken module, slapped in a fresh swap-in unit straight into the chassis, and went to lunch. But to print modern transistors down to a scale of just 3 nanometers wide, which, for context, is roughly 25,000 times thinner than a single strand of human hair, ASML required an almost impossible level of physical optics. To get it, they locked themselves into an exclusive high-stakes alliance with Germany's premier lens manufacturer, Carl Zeiss, eventually acquiring a massive 24.9% stake in their semiconductor division to prevent anyone else from touching it. I was 12 years old when I found out about Carl Zeiss from my Nokia N97 Mini's lens. Who knew then that they were also enabling the quantum leaps in the tech that I'm using today? Zeiss proceeded to develop reflective mirrors polished with literal atomic level precision. To visually understand how absurd this is, if you were to scale just one of these Zeiss mirrors up to the physical geographical size of the entire nation of Germany, the single tallest mountain bump or imperfection left on its entire surface would be less than 1 millimeter high. This is in manufacturing. This is rewriting the limits of what is physically possible. This insane level of precision is mandatory because ASML utilizes extreme ultraviolet light, or EUV. EUV light is highly sensitive. It is so easily obstructed that it is instantly absorbed by normal atmospheric air and standard glass lenses. As a result, the entire internal optical core of the machine has to operate inside an ultra-high vacuum state, reflecting the light down to the silicon wafer using Zeiss's near-perfect mirrors instead of passing through normal glass. And generating this invisible EUV light requires an engineering process that reads like a ridiculous science fiction novel. Inside the machine, ASML fires 50,000 droplets of molten tin per second through a vacuum, a high-powered industrial laser built by Trumpf, then shoots each individual droplet twice, The first pulse flattens it, and the second pulse vaporizes it into a plasma cloud that is 40 times hotter than the literal surface of the sun. Easy, routine, and completely normal. SpaceX just launched a historic $75 billion IPO to fund Elon Musk's dream of a massive chip terafab. But his move fast and break things playbook flatlines at ASML. SpaceX can blow up prototype rockets for data, but destroying a single 400 million ASML EUV machine triggers global supply chain paralysis. This cultural clash exploded on June 11th when ASML workers openly revolted during Musk's closed-door summit pitch. The ultimate reality? SpaceX's own blockbuster IPO filing admits their entire precision tech alliance is completely non-binding. Perfecting this process took over 3 decades and cost well over $9 billion in research and developmental capital. When the financial risk threatened to bankrupt ASML entirely, they pulled off a legendary corporate power move. Instead of waiting for a savior, they launched a co-invest program in 2012, effectively forcing their own biggest future customers, Intel, Samsung, and TSMC, to hand over billions of dollars to fund their R&D in exchange for small equity stakes. They literally made their clients pay to build ASML's monopoly. But today, this unbreakable monopoly is facing its most dangerous cracks yet. First, a geopolitical hammer. The Bipartisan Match Act proposed by US lawmakers in April 2026 is moving to shut down not just advanced sales, but the high-margin servicing of older, deep ultraviolet tools inside China, threatening up to 20% of ASML's future revenue. Second, a full-blown customer mutiny. TSMC, the world's king of chip manufacturing, announced they are delaying the purchase of ASML's brand new 400 million high-NA EUV machines until at least 2029. Why? Because TSMC's leadership stated point blank that they are simply too expensive to justify the math of Moore's law. Instead of paying ASML's eye-watering upgrade tax, they are choosing to squeeze older tools using complex, multi-patterning workarounds. And the sharks smell blood in the water. Canon is aggressively rolling out Nanoimprint lithography, physically stamping transistor patterns into silicon wafers with zero expensive EUV lasers. Meanwhile, a secretive Silicon Valley startup named Substrate, backed by Peter Thiel's Founders Fund and CIA's venture arm, recently emerged with a $100 million war chest to build a complete particle accelerator-based X-ray lithography system. They claim they can bypass ASML entirely and slash advanced wafer production costs from $100,000 to just $10,000. Ultimately, the global chip war is fracturing into incompatible regional fortresses. Even with unlimited funding, replicating ASML's institutional engineering knowledge would take any rival nation up to 15 years of grueling trial and error. In the modern race for technological supremacy, the ultimate gatekeeper isn't Washington, Beijing, or Tokyo. It is a single company in Netherlands managing a giant machine that vaporizes flying tin droplets with lasers.